Hello and welcome to this BRTSys IoTPortal video on the LDSBus USB adapter. Here we can see the hardware features of the LDSBus USB adapter. This includes a USB-C port to connect to a host PC or laptop, an LDSU port to connect directly to sensors or actuators, an LDSBus port which can be used in conjunction with the LDSBus Quad T-junction to connect to sensors or actuators, and a 24-volt DC power adapter which is used for the LDSBus port. So, what are the use cases for the LDSBus USB adapter? The first of which is to configure sensors and actuators for use with the IoTPortal system. It can also be used to calibrate sensors, perform firmware updates for sensors and actuators, can be used for sending manual commands to a sensor or actuator for testing purposes, and finally you can use it to create a local sensor actuator system using a computer system running our LDSBus SDKs. This feature will be covered in a future video. Here we can see a typical IoTPortal application, where an IoTPortal gateway is connected to an LDSBus Quad T junction, which in turn is connected to some sensors and actuators. However, before we can use these sensors and actuators in our application, they must be configured. By zooming in on the LDSBus network, we can see that our sensors and actuators have some attributes. The first of which is the LDSU ID, which is used to identify the actuator or sensor on the network, and by default before configuration, this is a value of 126. We can also see that there's the LDSU termination state, which can be set to on or off, depending on where the sensor or actuator is on the network. And finally, we can see that there's a nickname we can associate to the device to make it easily identifiable. For example, in this network, we should assign appropriate LDSU IDs to the devices, set the termination to on for the two-channel relay, and we can also set some nicknames which are helpful for identifying each device. To achieve this, we can use the LDSBus USB adapter in conjunction with the configuration utility while using the following hardware configuration. On our PC or host laptop, we can launch the LDSBus configuration utility. Going to settings, we can select the LDSBus USB adapter that we wish to utilize. From here, we can create a new LDSU project. We can enable the LDSU port power, and then select Scan to scan for LDSU sensors or actuators that may be connected. Here we can see the device details of a connected CO2 sensor. On the left, we can see sensor details such as its unique identifier, UUID, its serial number, its LDSU class, its current calibration values, the number of I2C devices, and its current firmware software version. We can see that its LDSU ID is set to the default 126 and requires configuration. We can use the drop-down menu to select a new LDSU ID. We can also select the termination status, whether that be on or off. And we can set a helpful nickname to help us identify the device. Once we have configured our desired settings, we can select the Update button to update the configuration for the device. Here we see the update is successful. We can also update the firmware of attached sensors or actuators via the Firmware Update tab, which opens the default installation folder's firmware files. If we select the file we wish, and then click Yes to confirm the update, we can see here we're updating from version 2.2 to version 2.3 of the firmware. Click OK, and the update process will take place. Here we can see the firmware is updated successfully. If we then reselect Scan, we can see that the software version is updated to 2.3. The Commands tab can be used for testing and verification purposes by sending commands manually to attached sensors or actuators. Here's the list of commands that can be sent to the device, such as reading or writing from I2C registers, or getting the UUID or info from the device. If we select the command we want to send and then press send, you can see that the payload is returned with the UUID of the device. Navigating back to the sensor via the LDSU tab, we can look at the final feature of the utility which we're going to cover today, which is the calibration feature. Selecting Calibrate gives us the following pop-up, which notifies us that 24-volt LDSBus power is required to calibrate a sensor, and it must be attached to an LDSBus quad T junction and connected to the LDSBus port of the USB adapter. If we select OK, it will allow us to do this. Here we can see the hardware configuration required to calibrate an attached sensor. Some sensors and sensor adapters require calibration before first use, while others require regular calibration. After we've made the hardware connections, the utility will ask us to switch to LDSBus port power. This will give us a countdown, allowing the power switch to occur, after which we can start the calibration. Hit OK and the calibration routine will commence. Once the calibration routine has been completed, we can update the calibrated values via the Update button. Here you can see the update has been successful. The utility will now turn off the LDSBus port power and ask you to place the sensor back into the LDSU port of the USB adapter. Please see the links below or our BRTSys website for individual videos on how to calibrate our LDSBus sensors and sensor adapters. Thank you for watching this BRTSys video on the IoTPortal LDSBus USB adapter.